Hello, young men. So we're looking at tape diagram for equivalent ratio. We went over it last week, and we said that it's more of a conceptual strategy to help us kind of understand equivalent ratio a little better. So this says write two or more ratios that are equivalent to 3/4. So let's say we have our ratio. And because there's not really a description of what the ratio is, we're just going to call it unit 1, unit 2. Unit 1, or the first quantity, represents 3. So we're going to represent it as 3 boxes. Unit 2, which is quantity 2, we're going to represent as 4 boxes because the second part of the quantity says 4. And that's our original ratio that we're trying to create equivalent ratios for. Now, there's a few pieces to this representation. We have the total for unit 1, the total for unit 2, and the total of the entire ratio, or the total of the entire two parts of the ratio. So because it's equivalent ratio, we know that it's basically being magnified, if you will. So that means if I'm trying to magnify it by 2, and I put 2 into one of the boxes, every box has to have a 2, because every piece of the tape diagram is equal. Now remember, we said unit 1 is represented here, and the total for unit 1 goes here, which would be 2, 4, 6. This represents unit 2, so the total for unit 2 would have to go here, 2, 4, 6, 8. And then the total of both quantities will go out here, which would be 14. Which means we're saying that 3/4, or I should say 3 to 4, is equivalent to 6 to 8. And we're going to look in a moment to determine whether that's true or not. Now, remember it says 2 ratios. So now, once again, we're going to create our tape diagram. 2 units. It's still the 3 to 4. So for unit 1, we represent 3. Unit 2, we represent 4. As I stated a few moments ago, it's equivalent ratio, which is basically similar to magnifying the amount. So now instead of putting 2 in each box, let's put 5 in each box. Because like I told you guys in class, once you put one number into one of the boxes in the tape diagram, you have to give every box that number because that's supposed to be equal, equivalency. And you can put any number you want, but it has to be the same number to establish equivalency. So now, unit 1, total, 5, 10, 15. Units 2, 5, 10, 15, 20. And our total would be 35. The total is not important for this, but it's great to practice writing in the total because it applies more to ratio word problems. So now we're saying that 3 to 4 is equivalent to 15 to 20. So now we're going to check because we have 3 to 4 is equivalent to 6 to 8, and also 3 to 4 is equivalent to 5 to 20. So let's do our check. And we know that we check using our procedural strategy, butterfly method. 24, 24. So that checks. And then we're going to compare 3 to 4 to 15 to 20. And we know that 15 times 4 is 60. 20 times 3 is 60. So that also checks out. Now, tape diagram is a great strategy when you encounter equivalent ratio problems because it helps you understand, or it helps you to create a visual representation to represent what is being asked in a word problem. But it also can be used just to find simple equivalent ratios. All right, your homework that will be due on Wednesday, October 11th for the tape diagram video. You're creating a tape diagram to show that for every 4 yellow cubes, there are 6 blue cubes. If there are 48 blue cubes, how many are yellow? You're going to write this word problem out. Make sure to annotate it. And I want you to use tape diagram to solve it. This will be due once again October 11th, Wednesday, because as we discussed in class, because there's no school Monday, I'm not going to make you guys bring in the homework on Tuesday. I'm giving you an extra day to complete it. Okay? Peace and love, and I'll see you guys on Tuesday. If you have any issues, go back to the beginning of the video and or look at your notes from class.